Welcome to solverfy.
To find the total effective dose that was absorbed by the worker, we first need to find what is the total energy that was absorbed. Now the total energy absorbed, we're gonna need the number of decays, total number of decays, right? Multiply that with the energy that's released per decay. Now in this case, we have the source to be cesium, and we are given that the half-life, or T half, is 30 years. Now since we are only interested in a particular period of 1.4 hours, right, which is way lesser than the half-life, so we can assume safely that the activity will be constant throughout the entire 1.4 hours. So we can find total energy being absorbed based on the total decay, right? So the total number of decay will be 1.2 microcuries. We're gonna convert this curie into decays per second by multiplying by 3.7 times 10 power 10. Right, decays per second for 1 curie. Then we multiply this by the energy released per decay. That is 190. We are given it's 190 kilo electron volts for the beta and 660 for the gamma. So that is a total of 190 plus 660 keV. And we are given that the total time is 1.4 hours, right? So we gotta convert from seconds to hours. So that's 1.4 times 3600. Right. So this will be total number of seconds. And finally, we will need to convert our energy to joules, right? Since dose is in terms of joules per kilogram. Then we'll convert that kV to joules by multiplying by 1.6 times 10 to the power of minus 16 joules per kV. We should get 3.043 times 10 to the power minus 5 joules. So this is the total amount of energy that is released by the cesium and is absorbed by our worker. Now next, we want to find what is the dose, right? And the dose in terms of energy is energy divided by the mass. We are given the mass is 62 kilograms. So this is in terms of joules per kg. But what we want is in terms of REM. So first we gotta convert to rads. Right, so rad, 100 rad is equals to 1 joule per kg. And to convert from rad to REM, we need to multiply by the RBE. But we know that the RBE factor for both gamma and beta is about 1, so that is just 1. So our final answer, we should get 4.9 times 10 to the power of minus 5 REM.